Good afternoon, dear judges. My name is Yen-Chen Chen. My project is about paraboloid tank tuned liquid damper, which is a kind of device consists of several water tanks with water partially filled and put it on top of the structure. And during the vibration or the earthquake, the water will slosh inside the tanks and it will provide an opposite force to the structure and mitigate its vibration. And in this study, I will use the paraboloid tank as a curved bottom tanks to fill the water because of the three benefits. The first benefit is all the water inside the paraboloid tank will participate in the procedure of the sloshing, which means I can use the least amount of water to effectively mitigate the vibration of the structure. And second, is that when the water is sloshing inside the water tanks, when the water goes up and the wave height will goes up and it will cause the effect called breaking wave, and it can dissipate large amount of energy and dissipate the vibration energy of structure. And the third is that the breaking wave will trigger the fluid to rotate all around the water tanks and disperse the vibration energy of the whole structure. That's why I want to use the paraboloid tanks to this device. So in my experiment, 6 different curvatures of paraboloid tanks were mounted on the top of the structure with a water mass ratio of 0.7, 1.0, and 1.5%. That means the mass ratio of the water compares to the structure. And the excitation amplitude of the structure is 1 and 2 centimeters respectively. And in my study, I will use a coefficient called alpha to quantify the effect of vibration mitigation. And the larger the value of alpha, that means the vibration mitigation effect is very significant. Okay, so my experiment found that if the frequency of the sloshing fluid inside the water tanks is close to the vibration frequency of structure, the effect of vibration mitigation will be the most significant. And this is what happened. Okay, just wait a second. You can see if the frequency of the water is not close to the structure, and the water will only slosh to and fro in the direction of vibration. However, if the frequency of the sloshing fluid is close to the vibration frequency of structure, then the water will first the breaking wave occurred, you can see, and then it triggered the fluids to rotate around the water tanks, and the vibration stops immediately. So that's a significant difference. And also, it's proof that compared to the condition that before the rotating fluid occurred, it's proof that the rotating fluids can provide opposite force up to 5 times compared than the condition that before the rotating fluids occurred. So that's why it can mitigate the vibration very effectively. Okay, so but it has a problem. It's that the rotating fluid will also trigger the structure to rotate, so it will make the structure unstable and unsafe. So we need to solve this problem. So my solution is just wait a second. I just use a flow guiding vane inside the water tanks, which can control the water to rotate in the desired direction. And I just control 2 pairs of water tanks, and water in one tank rotate counterclockwise, and another one rotates clockwise, so that it can effectively reduce the lateral displacement of the structure, and it can also increase the mitigation effect of the vibration by about 20 to 30%. Yeah, so that's why we need this device to guide the flow and to mitigate the vibration better. Okay, so my conclusion is the paraboloid tank to liquid damper can effectively mitigate the vibration of the structure during the huge earthquake, and under a certain condition that the rotating fluid occurred inside and with the guide vane installed. And in the real life application, we have a problem because we cannot predict the direction of the earthquake. So we need to modify our device. Is that to arrange 4 paraboloid tank in the square, and we need to install 4 flow guiding vanes inside the water tanks so that it can guide the flow no matter how the vibration is going. Yeah. And also, I've done a simulation program about a 40 layer building with a parabolic tank to liquid damper installed. It's proved that we only need each tank for about 5.8 meters in diameter and 1.3 meters tall. So it's almost applicable to that kind of building. Yeah, so that's about my project. Okay.
Thank you very much.
Yeah.